Okay, hello everyone. Now this is a follow-up from the previous video on liquid pressure. Now in the earlier video, we shared that P equals H rho G, where P refers to liquid pressure, H refers to vertical height, rho refers to the density of liquid, and G refers to gravitational field strength. So in this problem here, we are given that the surface of the water in the domestic cold water tank is 5 meters above the downstairs cold water tap. So what you have is there's a height difference of 5 meters. So your height will be 5 meters. And you're given that the density of water is 1000 kilogram per meter cube. And your gravitational field strength is 10 Newton per kilogram. So what is the pressure of water as it leaves the tap? You just apply the formula directly. P equals H rho G. And the vertical height is 5.0. The density is 1000. And the gravitational field strength is 10. And you will get 50,000 Newton per meter square. So that's the pressure of water as it leaves the tap. How about the next question? A tall cylinder contains mercury at a depth of 30 centimeters. I think this problem we may have to draw what the model looks like. Here the model here, a tall cylinder contains mercury at a depth of 30 cm. So this is 30 cm. Now recall earlier that we have to convert the variables to SI unit because the gravitational field strength is in SI unit. So when I see 30 cm here, immediately I'll just convert it to 0.30 meters. I don't have to wait for further instructions, just convert it. The area of the base is 4 cm square. So the area of base is 4 cm square. So now we have a cm square. It's going to be a little bit tricky. Don't worry, I'll show you how it can be done easily. The density of mercury is 13,600. So density is 13600 kilogram per meter cube. And the acceleration due to gravity is 10 meter per second square. Now, all our variables are expressed in SI unit except for base area. So how we going to convert the base area to the SI unit? So that means we need to convert cm square to meter square. How are we going to do it? Now, it's very reckless of some students. They will just try to remember whether it's times 10 to the power of 4 times 10 to the power of minus 4. You don't have to do that. Okay, save your brain juice for more important things. So to convert cm square to meter square, always go back to the very basic numbers that you're familiar with. For example, how do you convert cm to meters? That I'm very sure everyone knows. We know that 100 cm equals 1 meter. And if I want to square one side, I have to square the other side. The reason for squaring is I'm trying to convert cm to cm square and meter to cm meter square. So that's the reason for it. So once it's done, I will have 10 to the power of 4 cm square equals 1 meter square, because 1 square equals 1. And so if 10 to the power of 4 cm square equals 1 meter square, 4 cm square equals 4 times 10 to the power of minus 4 meter square. So immediately write inside, this equals to 4 times 10 to the power of minus 4 meter square. So now that we have all the numbers in place, how do we calculate the pressure that exerts at the base? So pressure equals H rho G. Vertical height will be 0.3, density 13600 G10. And then we have 40800 Newton per meter square. So that's the pressure you have. How about the force it exerts at the base? Okay, for the force it exerts at the base, we start from the very basic. We start from pressure equals weight over area. We know the area is 4 times 10 to the power minus 4. The pressure is 4800 equals weight over 4 times 10 to the power minus 4. So we have weight equals 16.32 newtons. So the weight is actually the force it exerts on the base, which is equals to 16.32 newtons.